All right. Well, I have the same reminders up again as from yesterday, so try to keep up as best you can with your assignments.
I
Check
am.
your grades daily. I've got to get caught up on some grading myself. Um, any missing assignments, remember it'll be a 0 until you turn them in. And
All
then
right.
if you miss a Google Meet, it'd probably be good to watch it before you do those assignments in case we did something together. Just kind of remind people each day about that. I want to go to, is this my right one? Yeah, I just got to get to home. Today's going to be a little bit different. I'm going to take you through a new virtual lab program that I'm hoping that we're going to get so that you can get an idea of, and I'd like to know if you think you would like it or whatnot. But we're going to do attendance first.
All right. Yeah, because
So
I didn't understand the attendance.
yeah, I know. I had to modify, change my order of doing some stuff. So for the attendance, if you'll have it up, I'm going to move back to a Jamboard. And hopefully, can't remember if we did any of this last year or not. Um, but remember, if we're converting, we did King Henry does usually drink chocolate milk.
Yeah,
And
we did
so
that.
you move. So if it's a letter by itself, you start at the U. So with this first one, we're going to start right here. And we're going to move to the K, which is to the left. So I'm going to hop to the D, that's 1, hop to the H, that's 2, hop to the K, that's 3. So when I move my decimal 3 places to the left, my new number is 5.73, and you can put the 0 or you can leave the 0 off. So that's the answer for number 1. For number 2, you're going to start at the M and you're moving to the C, so it's 1 movement back. So you're just taking 1 0 off, and so it is 2200. And then the third one, if you start at the K, we're going all the way to the end, and that's going to be 6 places. So 1, 2, 3, 4, 5, 6 to the right. So when I move that 6 to the right, it's going to be 77000 milliseconds. So for 1, 2, and 3, there's the answers. You want to make sure you get them down. So when you come over here,
Yeah, I'm trying, but my canvas is going slow. All right, there you
you
go.
might want to jot them on a sheet of paper.
It's
So
it's loaded. It's loaded now.
see if I can. Well, darn, it took it away. All right, so number 1 was 5.730 kiloseconds.
So it was what? 5.730.
5.730. Number 2 was 2200. Let me get the units. CG. And the number 3 was 77 with 3 zeros. 77123, and that was milliseconds. So I had originally planned that that's what we would have done yesterday, but one thing took
What was the last one?
right here, 77000 ms. Well, that's number 3.
MS.
Yeah, ms for milliseconds. And then it says, what is the base unit for volume? Volume is measuring how much space something takes up, and it's the liter. And length is the meter. And then you'll submit those. As I was saying, originally, that's what we would have done we would have had that lesson yesterday, but I'm like 1 or 2 days behind based on one lesson taking more time than I thought. If you go back and look, yesterday we had some lab safety things. 2 of those are actually due today. So if you didn't get them done yesterday, you still got time to do them today. We're going to actually look at an online demo, and I tried to put the link to it, but you can't link to it because you don't have rights to it. So when you get on this online lab demo, you're just going to ignore the link. I can actually use the link. You can. It'll give you an error message. So what I'm going to do is I'm going to take you through a new lab program. It is kind of it's 3D, and you get to kind of move around in the lab a little bit. And it's I feel like it's better than some of the ones I'd used last semester. Definitely not as they still take about 30 minutes to do, but it's not as tedious as the other ones. It doesn't, you don't have to click here and do, and type something and go back. It's all within the program. And I'm hoping to get these programs or this program, at least 8 of these that I'll do within my biology class. But the lab safety one I can do with everybody. So I wanted to kind of get students' opinions of what they thought about it. The only negative is it does take a while for it to load at the beginning. So it'll take a minute or so here. Sometimes I can click off and I click back and it speeds it back up. And sometimes it doesn't. Well, there we go. Cancel. So I know that a lot of y'all like to play games and things like that. And so there is kind of that aspect of it in that you're maneuvering around like you would inside a game. And so almost there. Well, if it'll load. There we go. All right, so if I had the student version, this is what you would see, and you would click Start. And so I'm just going to kind of take you through it.
Welcome to the lab safety simulation. I am Dr. One, your AI lab assistant. Today, you will learn everything you need to know to survive your first day in the lab. Are you ready for the challenge? This simulation uses voiceovers. If you don't have audio, click the speaker symbol on the top right of your lab pad to switch the play mode. If you disable the sound effects, the lab pad will slide up whenever there are instructions to read. You can select what type of audio you prefer, deselecting any of the Using the lab pad is an important way to get the most out of this simulation. Is this the first time you've played a Labster simulation?
All right, I'm going to click no here, but if this was your first time as a student, I would encourage you doing yes.
First, find a lab coat.
All right,
click on it to put it on.
Notice the arrow points which direction to turn in the room, and I'm using my mouse, clicking down and dragging to get there. And I've put a USB mouse in because it makes it easier for me to do that.
Now pick up the safety goggles and you are ready to go. Click on the door to enter the laboratory.
Say what?
This lab
I
is
thought you
used
said
by
something.
first-year
Oh, no.
chemistry students
Just listen to this.
in safest condition. Have a look around and identify the different hazards. Find 5 safety hazards and click on them.
All right, so I'm going to move around and find 5 things that are wrong. And so if you kind of hover over, it kind of tells you. So a cluttered workbench is one of them. So I'm going to click here.
That's it. This bench looks very messy. It is important to keep the lab bench tidy. Any clutter should be cleared away before starting a new experiment, and there should be no hazardous chemicals left on a workbench. 1 hazard down. 4 more to go.
All right.
Identify the hazards by clicking on them.
All right. So I'm just going to kind of, well, what did I do? There we go. Oh, I went all the way around. There's one right here.
For sure, chemicals need to be stored in designated cupboards and not just placed on the floor. This is especially important for reactive chemicals. Flammable liquids need to be stored in fireproof cabinets. There are 3 more hazards. Well spotted. Every lab has 2 emergency exits which ensure that nobody gets cornered in the event of a fire. The emergency door isn't any good if it is blocked by objects. Click on the handcart to move it to a safe location.
Well, there we go.
Well done. The emergency exits have to always be clear. There are 2 more hazards. Can you find them?
Oh, there we go. The sink is the other one.
A sink full of dirty glassware isn't a nice surprise. Make sure you always clean, dry, and put away the equipment after every experiment. Let's remove the glassware.
Oh, gotta click on the glassware.
Beautiful, clean and tidy. There is 1 more hazard. Click on it.
It took me a while to find this one the first time right here because we don't have one of these here.
The fume hood constantly draws air through a filter to ensure that you don't get in contact with dangerous chemicals. The airflow only works effectively if the glass sash is pulled down. Let's close this fume hood. What a relief. Now the air is safe to breathe. Time to take care of the hazardous chemicals on boxes. Click on them to have a closer look. Click on the bottle containing flammable liquid. Check the media. Well done. The red diamonds on the bottles are called hazard symbols. Each of them depicts a different hazard. Have a look at the following overview of the different hazard symbols.
All right, now here, when this pad comes up, you can click on theory, and it actually has written out everything that the computer is saying. And then media has the images. So when you click on media, they've shown you this one so far, so you can look at it up close here. And then when you're done, you just click back to home and click to continue.
Oxidizing reagent.
And if you would go back to media, you can look. Oxidizing reagent is actually going to be D, is that symbol.
Oxidizing reagents are very dangerous because they can accelerate chemical reactions, such as fires, by providing electronegative atoms. What does the following symbol mean?
Because it's inside of a human body, it's going to be a health hazard.
There are many kinds of health hazards. Substances with this symbol can cause respiratory problems, induce mutations and cancer, or may be toxic to specific organs.
And if you couldn't remember, again, you could go back to media and
Here's
click
an
on
image
it.
of the hazard symbol on the box. What does it mean?
All right, this is explosives because it's
These
exploding.
chemicals definitely don't belong here. Imagine if somebody walks into the pile and the glass bottles fall onto the floor. If they break, they could light a fire, and the explosives next to them would certainly produce a bombastic news story.
And so then you continue.
Click on the bottles to remove them. Let's get rid of this safety hazard. Click on the cluttered workbench to tidy it up. Oh dear, this workbench is a real mess. Hopefully, you will never see something like this in a real lab. Let's take care of the problems one by one. Start with turning off the Bunsen burner. It is very dangerous to keep an open flame unattended. Turn off the Bunsen burner flame. Great. Now click on an object that you should never bring into the lab.
All right, so in the lab, we never have food or drink.
Well spotted. Food and drink are strictly prohibited in the lab. Imagine if somebody grabbed the wrong bottle by mistake and took a sip of the toxic substance. There's another object that doesn't belong here. Find it.
And right here, your backpacks or other
Exactly.
personal things aren't
equipment is
there.
not supposed to be placed on workbench surfaces. Could you imagine what would happen if this backpack caught fire? Before you touch anything else, better wear gloves. There is a living organism on this bench. Can you find it?
Notice the arrows pointing us which direction to turn, and then it's pointing at it.
Oh, have a look at this. There is a bacteria colony growing on this agar plate. This might be some dangerous pathogen. We need to use a special bin for biological waste. Discard the petri dish with the unknown bacterial sample in the biohazard waste bin. There is still a protocol from a previous experiment on the table. Clean up the lab protocol. Oops, you just spilled a hazardous chemical. Have a look at the hazard symbol on the beaker. What does the hazard symbol on the beaker mean?
If you didn't remember what that was, you would go to media, you would look here, and it is corrosive. So you're going to go back to home, and you're going to answer
Brilliant.
that.
This is you only need a tiny drop of the indicator. You can use a micropipette for this. Now pick up a pipette tip from the box. Draw up a drop of the indicator liquid. Now add a drop to the spill to identify if it's an acid or a base. Fantastic. When you added the indicator liquid to the spill, the drop turned red. This means the spilled chemical must be a strong acid. We need to neutralize it before cleaning it up. Now add a drop to strong acids react with your skin can cause burns. That's why it's very important to protect your hands with gloves. Spills of strong acids or bases have to be neutralized before you can dispose of them. Sodium bicarbonate is the chemical term for baking soda. It neutralizes the acid, and the remains can be scooped into a plastic bin and discarded. Let's neutralize this acid spill. Pick up the baking soda. Put baking soda on the spilled solution. Well done. Now put the neutralizer back on the shelf. Now it is safe to use an absorbent paper to clean up the spill. The neutralized acid can be disposed of in the solid chemical waste. Usually, the chemical waste is stored in a fume hood. During the cleanup, your gloves got contaminated. You need to dispose of them to avoid spreading chemicals over everything you touch. Click on the trash bin to discard your contaminated gloves. Why didn't you just clean the spill with water?
All right, water and acid is very, they react together.
Superb. If you drop water into strong acid, they react and produce a lot of heat. The reaction could potentially lead to splashes of acid. A drop of such a corrosive chemical in your eye could cause serious damage and lead to blindness. That's why it's essential to wear safety goggles all the time. Now, just because this is a virtual lab, let's do something crazy and simulate a situation in which you don't wear any safety goggles. Don't try this at home. Put the goggles on the bench. Pour the beaker containing the unknown acid solution into the bottle with the unknown toxic liquid. Like I said, don't ever try this at home. This seems to have triggered an interesting reaction. It seems potentially dangerous. What should you do now?
You never want to put a lid on something that has a fume coming out of it like that. You want to evacuate the
Definitely. If you
lab.
have no idea what kind of chemicals you are dealing with, you better get out of the lab until the danger is contained. In this case, we will do the opposite to show you what can happen if you make this critical mistake. Hopefully, you will remember this for the rest of your lab career, and never do it. Let's see what would happen if you close the bottle. Oh no, you've got acid in your eyes. Quickly go to the red safety station next to the emergency exit. Push the toggle at the safety station to rinse your eyes with water. After washing the acid out of your eyes, you should immediately consult a doctor. Your eyes are very fragile and it is very important to protect them with safety goggles at all times. Why is it dangerous to wear contact lenses in the lab?
You can get liquid trapped under
The
them.
chemical splash might get in between the lenses and the eyeball, and stay there even when you start washing your eyes. If you wear contact lenses, follow the. Your decision to evacuate the lab has been reconfirmed. If something is steaming or bubbling, you should never close it. If the reaction continues, the pressure will increase until it explodes. Congratulations on your smart decision. Now, can you find the fire blanket? What should you not do if a person's clothes suddenly catch fire? You got it. The most effective way to extinguish burning clothes is by rolling on the floor. Water is also a good choice if it's in close proximity. If you see a burning person running down a corridor to reach a safety shower, stop them and try to smother the fire. Never use a fire blanket on a standing person. The blanket may create a chimney effect that can intensify the fire and burn the person's face. What would you use if there was an open fire in the lab? Precisely. There are usually two different types of fire extinguishers: carbon dioxide-based extinguishers and foam-based extinguishers. Never use a carbon dioxide-based extinguisher on a person. Do you know the reason why?
Right, if you didn't know why here, you would go to theory and you would see that here, you keep scrolling down. Carbon dioxide extinguishers are very popular. They can be used for class B and C fires. Do not use them on people as they will cause serious frostbites. Well, if it causes frostbites, it means it must be freezing cold.
Carbon dioxide is compressed inside the extinguisher and becomes freezing cold when it's released. What is the first thing you have to do if there is a fire in the lab?
You would think probably let's get a fire extinguisher, but you need to tell other people that there's a fire. So you'd want to alert them
Precisely.
by
Fighting
pulling
the
the fire
fire is
alarm.
only a priority when everybody is safe and aware of the danger. It's important to stay calm and first figure out what type of fire you are dealing with. Some fires actually get worse when you throw water on them.
Grease fire in your kitchen is one such that if you put water on it, it will make it worse. So you want to cover those or put, I think it's baking soda on them to put those fires out.
Great job. You're a safety expert now. Your friend, Lucy, just entered the lab. She has never worked in a lab before. Teach her what you have learned today. What lab safety protocols is Lucy violating? You can always lower the lab pad and have a look at her again.
All right, so remember before they let your simulated person come in the lab, you had to put on a lab coat and goggles. So she is not dressed properly.
That's right. Have a look at her again and click on different parts of Lucy's clothing to identify her mishaps.
All right, so from yesterday's lecture, we know that
Well
long
spotted.
hair.
When you are working in the lab, long hair should be tied back. Imagine if her hair catches fire on a Bunsen burner flame.
Also,
These loose sleeves are very impractical. You don't want your sleeves soaked in chemicals. Well spotted. Large jewelry can get in the way, fall into chemicals or cause a hazard and has no place in the lab. She looks pretty unprofessional without a lab coat, right? Not only do lab coats make you look like a pro, but they also protect your clothes and skin from any minor spills. That's it. It is compulsory to wear long pants in the lab to protect your skin from spills. Exactly. Toes should be covered to protect from falling objects as well as chemical spills. Good job. You have already learned why it's important to properly protect your eyes. Normal glasses don't suffice. Never forget to wear safety goggles. Well done. You have proven that you know how to work in a lab. What do you have to do before leaving the lab to make sure you don't carry traces of chemicals outside?
okay, there's two. A and D are very similar. You want to remove your lab coat first and then wash your hands because your lab coat could still have chemicals on it.
If there are traces of chemicals in your hands, you might, for example, transfer them to something that you eat later in the day. Let me ask you one last question. Do you feel like you gained relevant knowledge during this semester? Thank you for your feedback. Your score has been saved together with your 100% progress. Congratulations, you have completed the simulation. We hope you enjoyed it and you feel wiser now.
This would be the score that I would input if you had done this yourself. When you answer the questions, you get 3 chances to answer the questions, and you get less points each time. So this is about my 4th time going through this, so I knew them very quickly. So this is an example of a lab type that I want to get for us, especially for biology. Hopefully at some point in the future, I could get some for physical science as well. But when you get to biology, I hope to have access to some of these. And I can use this free one as demos for in physical science class. If you're still there, Camden, what did you think of that type of lab?
It was good.
A little bit better than what I'd done before, especially if
Yeah.
you could do it.
Yeah.
All right. So like I said, it's mainly going to probably be for biology. I don't know if I can get, enough for 2 classes or not, but I know that they're going to try to get me stuff for biology. So basically that was all I wanted to do, was demo that and get some input. I went to the wrong thing. If you look back at modules again, I want you to go back and finish up the lab safety stuff from yesterday, anything that you haven't done. And I'm going to put, I didn't get it added here. There's going to be a little 5-question quiz on this lab demo, and I'm going to put the video here. And so the recording here, so you could go back and look at it, but you should know the answers to those 5 little questions. But I'm going to add that there. So you'll have the attendance that you should have already done, and you'll have that one little quiz, and then make sure that these last 2 things here are submitted, as well as anything else submitted that you might haven't completed yet. So any questions about anything? All right, if no questions, then that's all that I have for today.
All right.
So I'm going to stop recording. Just make sure you stay up on your assignments, okay?
I will.